Hey guys, this is Gradius, and this is the video for exponents and simplifying expressions with exponents. And what we'll be doing a lot of is multiplying two numbers that both have exponents on them. Okay, so if you look at your I can statement, it says I can simplify expressions by using the properties of exponents. So we're going to learn new properties of exponents today, and they're going to help us really simplify these. So real quick, I just want to go over what exponents are. Just a quick little review. So this would be 3 to the third power. This is the exponent right here. Here is my base of 3 raised to the power of 3. Okay, so 3 raised to the power of 3. What this really means is that I'm taking this base right here and I'm multiplying it by itself the number of times that my exponents is. So I'm taking 3 and I'm multiplying it by itself 3 times. So 3 times 3 times 3. This is not just 3 times 3. This is 3 times 3 times 3, so multiple times. And 3 times 3 times 3 is 27, so 3 to the third power to the power of 3 is 27. So just quick basic review, which you guys should already know how to do. So what we're going to do is we're going to look at exponent problems like this, where I have a base raised to the power of something times another base raised to the power of something. So I have 2 squared times 2 to the 4th power. Okay, so 2 to the 2nd power times 2 to the 4th power. And if we actually expand this out, 2 squared is just 2 times 2, okay, which we all hopefully know is 4. 2 to the 4th power is 2 times 2 times 2 times 2, so I have 4 2's here. If I were to combine this, because really what I'm doing is I'm just multiplying these two pieces right here. So really what I have is just 2 times 2 times 2 times 2 times 2 times 2. I'm combining this with this because I'm just multiplying these two pieces right here. So I can kind of put the parentheses. I'm just multiplying them. So when I combine them, I have 1, 2, 3, 4, 5, 6. I have 6 2's, which is really just 2 to the power of 6. And I'm done. Okay? So I expanded 2 squared out to 2 times 2. I expanded 2 to the 4th power out to 2 times 2 times 2 times 2. So I kind of expand them out to what they really mean. And then I combine them together to actually be able to count how many 2's I have and simplify to just a base with an exponent, because this is a much easier way to write it than this. And this would be simplifying this expression. I'm done. That would be my answer. You do not need to actually figure out what 2 to the 6th power is. Okay, I just want this simplified answer right here. So a nice little rule for that, you guys, is this. When multiplying two powers with the same base, just add the exponents. So right here, I have the same base. They both have a base of 2, and here are my 2 powers. I'm just adding these 2 exponents, and I'm keeping my base, and that's all I'm doing. So I have 2 squared times 2 to the 4th power. That is 2 to the 6th power, because 2 plus 4 is 6. And that's all we really need to do. So we're multiplying 2 powers with the same base, just add the exponents. So right here, if we look at this problem, I have 3 to the 6th power times 3 to the 9th power. So I'm multiplying, okay? So now what I can do is I realize I have the same base, 3 and 3. So all I have to do is just add my exponents and I'm done. So 3 to the 6th times 3 to the 9th is just 3 to the 15th power. Okay, same problem, I have another problem right here. 4 to the 8th power, so just because this is in parentheses right here, this is still going to be 4 raised to the 8th power. This is still 4 raised to the negative 3rd power. Okay, so even though I have a negative exponent, it doesn't change the process. I have the same base. I'm multiplying these two numbers with the same base, so I'm just going to look at their exponents and add them. So this is really just 4 to the 8th power plus negative 3, because I'm just adding my 2 exponents, which means that this is 4 to the 5th power. Okay, negative 6 to the 3rd power times negative 6 to the 7th power. Even though I have a negative base, it doesn't change anything. My bases are the exact same. So I'm still going to just keep my base, which is negative 6, and add my exponents. 3 plus 7 is 10. And then finally right here, the first thing I need to check is see if I have the same base. I do not, so this is already simplified. I cannot simplify this anymore. So the answer to this is just 4 to the 6th power times 5 squared. This cannot be simplified any further because the base is different. Okay, so when we're multiplying 2 powers with the same base, just add the exponents. That's all we have to do. It's pretty simple. So now let's do something a little bit different. Now I have 7 to the third power. All of this is in parentheses, which means all of this is raised to the second power. So what that means is I'm taking 7 to the third power, what's in my parentheses, and I'm multiplying it by itself. So this is my new base. My base is 7 to the third. So what this means is I'm taking 7 to the third power, okay, and I'm squaring it. So I'm multiplying this by itself. So this expands out to 7 to the third power times 7 to the third power. Well, now this looks very similar, right? Isn't this just the same thing that we had before? 7 to the third power times 7 to the third. I have two numbers with the same base raised in exponents, so we just add the exponents. Okay, so this becomes, let's expand it out though, 7 times 7 times 7. And this one becomes 7 times 7 times 7. And I'm multiplying all these together, so it's just 7 times 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6, which is just 7 to the 6th power. Okay, so even though I have an exponent inside my parentheses and it's raised to another power, I have a power raised to another power, really this is still my base. So I'm still taking my base and multiplying it by itself however many times I'm being told to multiply it by itself. So 7 to the third raised to the second power becomes 7 to the 6th power. And this is the simplified expression. You do not have to take this any further. So let's look at a rule for that. When we raise a power to another power, we just get to multiply the two exponents and we're done. Okay, so let's go back and look at this again. I'm raising a power to another power. And what I do, if I just multiply these two exponents, 3 times 2 is 6. And I'm done. So for here, 4 to the third, all raised to the 4th power. So I'm taking my base and multiplying it 4 times. So really this is 4 to the third times 4 to the third times 4 to the third times 4 to the third. Well, all of these expand out to 3 different 4s. 3 4s, 3 4s, 3 4s. So I have that 4 times. So 3 times 4 is 12. This is just 4 to the 12th. And if I were to add these up as we learned earlier, this is 3 plus 3 plus 3 plus 3, which is 12. So 4 to the 12th. Same thing here. Now I have a variable in here. I have x to the third raised to the 5th power. So what I'm going to do is I'm just going to multiply these because I have a power raised to the power. My base is still x. Okay, that hasn't changed. Now I just have it to the 15th power. So just because it's a variable, nothing changes. Our process is all still the same. So this becomes x to the 15th power. Let's look at 2 more problems, very similar, and then we'll be all done with this video. So now, if we look at this example, I have 6x all squared. So now my base, I have 2 different things inside my parentheses that are being raised to the 2nd power. So really what's happening is every single piece inside of here is being raised to the 2nd power. So this is like taking my 2 and distributing it, my 2nd power, to both pieces. So this is the same thing as 6 squared times x squared. Okay, so I'm taking my power of 2 and I'm taking it and bringing it to both pieces. So I have 6 squared times x squared. Well, 6 squared is just 36. X squared, oh, we don't know what that is. That's still x squared. So this becomes 36x squared. This is still 36 times x to the 2nd power. Okay, so I'm still combining these. I'm still attaching these together in the end. But now I'm raising both pieces to the 2nd power. Let's look at one more. So I have negative 3x all raised to the 3rd power. So really what I have here is negative 3 raised to the 3rd power, and I also have x raised to the 3rd power. Well, negative 3 to the 3rd power, let's figure out what that is. That's going to be negative 3 times negative 3 times negative 3. Oops, that is an ugly negative 3. Let's redo this. Negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 9 times negative 3. This is negative 27. So this expands out to negative 27, and then I still just keep my x cubed right here, times x to the 3rd, and I'm done. Okay, those are all the rules we're going to learn with exponents for today. Okay, so I'll have future videos when we're talking about dividing exponents, and when we have negative exponents, how to simplify those. But just remember your basic rules. Okay, so if you have an exponent on the outside with multiple numbers on the inside, make sure you take your exponent and bring it and to kind of distribute it to both pieces inside. Okay, if we're raising a power to another power, just multiply the two exponents for a shortcut to give you an easy, quick answer. And then finally, if we're multiplying two powers with the same base, we're just going to add the exponents. So if I have the same base here, like 3 to the 6 times 3 to the 9, I'm just going to add 6 and 9 to get 15, and I'm all done. I hope this video helps you guys. Thank you for listening, and good luck.